we're starting today. Today and tomorrow are going to talk about solubility. Solubility are things that are soluble or that dissolve in something. So what we have here is what we normally do at school, a little experiment. We have hot water, like to make tea, and we have cold water. Okay? Or this is like cold tea, so it looks like tea. Okay? What we would have done at school is determine how many like scoops of sugar. We would do how many grams of sugar do you put inside in the cold sugar. We'll do 1, 2, 3. Okay, and you can see that in the cold sugar, look what's in the bottom. Okay, does it dissolve? No, you can see the sugar particles like floating all around. If you let it settle, they settle to the bottom still. Okay, there's all the sugar. I can scoop it on the bottom. I put 3 scoops in the hot tea. Is that even gonna make a dent in it? No. Can't see, but dissolve. Oh, looks just like water. Okay, so the hot tea or hot water can dissolve more sugar, so it is more soluble, we call it. Okay, cold things generally are less soluble. There are exceptions, but generally colder substances are less soluble, so they can put less in it. Hot substances are more soluble, so you can put more in it. Okay, now we're going to talk about solubility, but this gentleman has put all of the definitions on the screen, so we're going to listen to him talk about the different things right in the beginning, and then I'll talk about your worksheet.
So real quick, we're going to talk about solubility. Okay, there are some definitions and some terms that go along with this that you need to be aware of. We're going to be looking at solubility this year qualitatively and quantitatively. So there's sometimes where we're just wondering if things are going to dissolve, and sometimes we want to know how much is going to dissolve. Okay, so first we need to understand the parts of a solution. We know what a solution is already: homogeneous mixture, one phase. Okay, the parts of a solution are the solute. The solute is the part of the solution that dissolves. Usually it's present in the smaller amount. So there's usually less solute than solvent. The solvent is the part of the solution into which the solute dissolves. Usually that's the part of the solution that's present in a greater amount. Okay, so a solution is made of a solute and a solvent. Now most of the solutions that we deal with in chemistry are aqueous solutions. Aqueous solutions are solutions in which the solvent is water. Okay, so things are dissolved in water, and the solutes are usually salts or other compounds that mix thoroughly with water. So we'll be dealing primarily with aqueous solutions. So we have water as our solvent. Solute is variable. Okay, so what is solubility? Solubility is defined as the maximum mass of solute that will dissolve in a given mass of solvent at a given temperature. There's 3 parts to this then. We need to know the mass of solute, we need to know the mass of solvent, and we need to know the temperature that the solution is made at. And that will tell us what the solubility is. The solubility is the maximum amount of stuff that can dissolve. Okay? We can refer to solutions as being either saturated. A saturated solution contains the maximum amount of solute at that temperature. Or unsaturated. Unsaturated solutions contain less than the maximum amount, any amount less.
And I say the saturated solution is where it's on a graph and it is directly on the line, whereas the unsaturated solution, I call it below the line when we're looking at the graph, which will be described later.
And then finally there's something called supersaturated, but we'll talk about that later.
And we call that, when we're on the graph, that would be above the line when we talk about graphing.
Okay, so really we're talking about, when we talk about solubility, we're talking about making a saturated solution at a given temperature. Okay, so what are some factors that affect solubility? What are some things that affect whether or not something is going to dissolve? Well, for one thing, the nature of the solute, its structure, what it's made of, what it's like. There are some things that dissolve better than others. So you can put certain substances like sugar into water, and you can dissolve a ton of sugar into water. But in the same amount of water, something like magnesium sulfate or sodium chloride doesn't dissolve nearly as well. And that's because those substances are a little different in how they're put together. So the nature of the solute is kind of important, and we'll explore more of that as we learn more about compounds. Agitation, that just means stirring or shaking it, right? You can get things to dissolve a little bit better if you stir them up or if you shake them up sometimes. That's, of course, if there's enough water and if everything's working well. Temperature is another factor, and we've just talked a little bit about that in the definition of solubility. In general, solid solutes, solids that you want to dissolve into water, in general, they dissolve better at higher temperatures. The classic example of this is if you have iced tea versus hot tea, and you want to put sugar in your iced tea and you want to put sugar in your hot tea. It takes a lot longer for the sugar to dissolve in your iced tea than it does in the hot tea. In the hot tea, you put it in, it's almost gone instantly. But in the iced tea, it takes longer. And sometimes you get that layer of sugar at the bottom that doesn't dissolve. Well, that's because of the temperature. The colder the temperature is, the less solid dissolves. Gases are exactly the opposite. Gases do dissolve in water. That's how fish breathe. Fish can't breathe in water unless there's oxygen involved, and the oxygen has to be dissolved in the water. So with gases, solubility actually goes down as temperature goes up. So the hotter the water gets, the less oxygen is dissolved in there. And some species of fish are very sensitive to that. So if the temperature of their environment goes up even a couple of degrees, they may die out because there's not enough oxygen dissolved for them. Okay? And then finally, the relative amount of solvent. So if you want something to dissolve, if you add more water, usually you're going to get it to dissolve, because remember, solubility is the maximum amount of solute that dissolves in a given mass of solvent. You increase the mass of the solvent, you increase the amount of solute that can dissolve in it. Okay, so those are all things we can control about a solution to help things dissolve a little bit better. Quantitative solubility. So qualitative solubility is simply just will it dissolve or not. Quantitative solubility deals with the numbers behind it. We want to know how much solute will dissolve, and we want to know how much solvent is required and what temperature that's going to require. Okay, so
that's where we will stop him, and we will go to my worksheet that I made that we are going to see. So this is like what it looks like graphing. So as you can see, generally how he said the lines increase as the temperature. Okay, here's the solubility in grams, how much sugar you can put into that tea or ice water. Okay, and down here across is the temperature. So as the temperature increases as you go to the right, generally the more grams you can put into something. Like you said, there's only a couple that go down. Here's one that goes down as you go to the right. And I don't think there's another one on this graph. Okay. So what we're going to do now is, while looking at the KCl, so that is potassium chloride. Each of these are a different salt, they call it. They're a different compound that you can dissolve in water. Okay. Here's the KCl as this blue line. Okay. Guess we'll put that right up there. Okay, so point A, if you look at point A up here, that means that it is super saturated. If you put in this many grams at this temperature into KCl, you would have more dissolved than you normally would, because somewhere along this line is normally what you would have dissolved at this portion. So at this temperature, this would be how much? About 47 grams. If you follow it to the left, 47 grams is how much would be normally dissolved at this point. But we have dissolved this much, almost 70 grams. Okay? But point B, so down here it says, point B is considered saturated. It is the amount that can be actually dissolved at that temperature. I call it on the line. Here's the KCl. Here's on the line. At this point, it can have like 42 grams dissolved at about 53 degrees Celsius. Okay, that is exactly saturated because it is on the line. If we look at point C down here, it would be below the KCl line. So I would call that unsaturated. It has less than the amount that can be dissolved at that temperature. And that would be below the line. Okay, so you could dissolve this much more grams in order to get it up to the saturation point. Okay. Okay, now we're going to get into the numbers for the example. Is it, oh, sorry, we'll do an example first. Is it supersaturated, above the line, saturated, on the line, or unsaturated, below the line? So let's look at 30 grams of K2Cr2O7 at 50 degrees Celsius. So first we have to find the K2Cr2O7 line and see what color it is. Oh, here it is. And it looks like it's like purple. Okay. Okay, now let's see where the 30 grams and 50 degrees Celsius come together. Okay, where does 30 grams, so go on the gram side, go from 30, follow it all the way over to the K2Cr2O7 line. And then follow it at the 50 line. So 30 grams at 50 degrees. 50 degrees Celsius is right here. Okay, here we can mark a spot. Maybe I'll put a little dot there. Okay, that's the spot. So let's follow it. Is it going to be above the line, on the line, or below the line? So it's on the line. So because it's on the line, we call it saturated. Okay. So I highlighted that. That would be your answer that you would normally write in the blank, but I just put it here to show you. Okay, next one. We are going to deal with another of the numbers now, how to read the graph. How many grams of KClO3 can be dissolved at 70 degrees Celsius? So how many grams? That means our number will be over here on the left. We are going to be working with 70 degrees Celsius, and we're going to follow it up to where it meets our line of our salt that we're looking at. And we're looking at the KClO3 line, which is this brown one. So we're going to follow 70 up to the KClO3 where it meets that line. I put a blue dotted line here, and then follow it all the way over to the left and see how many grams can you dissolve at that temperature. And you would be able to dissolve 30 grams in KClO3 would totally dissolve, but you couldn't put any more. Okay, that's how to solve for grams. Now if we were to do it opposite, and I give you the grams, and we solve for temperature, okay, let's do that for our last example. What temperature would 20 grams of KNO3 be saturated at? Meaning it has to be right on the line. So let's find 20. Oh, we have to run across and see which one does it come in contact with. Comes in contact with lots of lines, so let's figure out where the KNO3 line is. KNO3 line is what color? KNO3 is green, so here it is. So let's follow the 20 grams across till you hit the KNO3, and it looks like I made a red line for this one. And then follow it down, and you see where it runs into the 10 degrees Celsius. So you would be able to dissolve 20 grams of KNO3 at 10 degrees Celsius, would make it saturated. Okay, what you're going to do now is use this knowledge, and I'll have this graph or one very similar posted on your questions so that you'll be able to answer questions that are very similar to these.